We discuss about the circuit breaker in the chapter circuit interrupting devices. So first of all, what is circuit breaker? So circuit breaker is a switch capable of making or breaking the circuit under no load as well as on load condition. Okay, it is a one type of switch. Okay, we already discussed the fuse, also the fuse. Okay, so now isolator is also one type of switch, but it is a air brake switch which operates only on no load condition. Okay, but circuit breaker is also one type of switch. Okay, but the function of the circuit breaker is to make or break the circuit under no load as well as on load condition. That means it will operate in both conditions, whether the circuit is on no load condition or on full load condition. Okay, so circuit breaker is a switch capable of making or breaking the circuit under no load condition and as well as on full load condition. Okay, so we can say that it can make or break circuit either manually or by a remote control. Okay, so we can make the circuit manually or we can make the circuit by remote control. Likewise, we can break the circuit manually or we can break the circuit remote controlling. Okay, a circuit breaker in conjunction with relay can break the circuit under faulty condition. Okay, so it is in conjunction with the relay. Okay, so when fault occurs, at that time this circuit breaker in communication with the relay can break the circuit. Okay, so it can also operates under the faulty condition. Okay, so we can say that it is a switch which can operate in no load condition, full load condition as well as the faulty condition. Okay, a circuit breaker can make or break a circuit either manually or automatically under all conditions. Likewise, no load condition, full load condition and faulty condition, or we can say that the short circuit condition. Okay, a circuit breaker is a piece of equipment which can make or break circuit either manually or by remote control under normal condition. Normal condition, that means there is no fault. Okay, so we assume that we have a two conditions, faulty conditions and a normal condition. So in normal conditions, we can make or break the circuit manually as well as remote control through the remote control. Okay, so another definition of circuit breaker, we can say that the circuit breaker is a piece of equipment which can make or break a circuit either manually or by remote control under normal conditions. So when there is no fault, okay, that is known as the normal condition. Okay, it break a circuit automatically under faulty conditions. Okay, first we can say that it can make or break the circuit under normal conditions. Second, we can say that it break a circuit automatically under faulty condition. Third, we can say that it can make a circuit either manually or by remote control under vague conditions. Okay, so we can say that a circuit breaker incorporates manual or remote control as well as automatic control for switching functions. Okay, so mainly the function of the circuit breaker is the switching function. It whether it make the circuit or it breaks the circuit. Okay, so it has a function of the switching. The later control employs relays and operates only under faulty conditions. Okay, so it conjunction with the relay or it communication with the relay can operate under the faulty conditions. Okay, so this is the basic information regarding the circuit breaker. Okay, now we'll discuss the elementary schematic diagram of a circuit breaker. Okay, so this is the elementary schematic diagram of a circuit breaker. Okay, so if we see the schematic diagram, so in this schematic diagram we have a supply line. Okay, these two lines are for the supply line. Okay, through the supply line it is connected with the sliding contact. So one terminal of the supply is connected with the sliding contact. Okay, So this is the one terminal of the supply that is connected to the sliding contact. So these are the two sliding red boundary color box. Okay, these two red color of boundary box. Okay, it has a red color boundary. Okay, so these two boxes is the sliding contacts. Okay, in between these two sliding contacts, or we can say that this sliding contact slides on the moving contact. Okay, so this pink color road is the moving contact. Okay, so on this moving contact, this sliding contact slides. Okay, now this second terminal of the supply that is connected with the fixed contact. So this is the blue color road. This blue color road is the fixed contact. It is not the movable contact. Okay, this pink color road is the moving contact which can move either forward or in the reverse direction. Okay, this moving contact can move in to and fro. Okay, and on this moving contact there is a sliding. So this moving contact slides under the sliding contacts. Okay, so the supply is connected to sliding contacts as well as the fixed contact. So the circuit is closed. So if we want to find a path of current flowing through the circuit, then it is like this. Suppose this is the positive terminal, then current will flow through the sliding contact, then it goes to the moving contacts and then goes to the fixed contact and it will return to the circuit. Okay, so this is the path of the current. Okay, now here is one CT is connected. Okay, CT, that means the current transformer. What is the function of the current transformer? Hers function of the current transformer.
સર કરંટ ને સેન્સ કરવાનું.
Okay, here we are using the CT to sense the supply current, or we can say that the current supply the current. Okay, so for this CT, this wire or this is, it is the primary for this CT. Okay, now on secondary side of the CT, the trip coil is connected. Okay, okay, for this CT, this wire is the primary and this coil is the secondary winding for of CT. Okay, understood now? For this CT, this wire is the primary and this coil, blue color coil, is the secondary of the CT. Okay, and secondary of the CT is connected to the trip coil. Okay, understood? The secondary winding of a
Yes, sir.
CT is connected to the trip coil. Okay, now this trip coil is connected with the automatic mechanism. Okay, this automatic mechanism is for opening and closing of the circuit breaker. This black boundary blue color box is the automatic mechanism. Now, so with the help of this automatic mechanism, we can open or close the circuit breaker contacts because it is connected with this handle. This handle is connected with the moving contact and it is connected with this automatic mechanism. Okay, so according to that, this handle operates or move the moving contacts in forward direction as well as in reverse direction according to the automatic mechanism operation. Okay, so this handle is connected with the operating mechanism and connected with the moving contacts. Okay, now when if we talk the normal condition, okay, normal condition, that means there is no fault in the circuit. Okay, so in normal condition, and we assume that circuit breaker is in on condition, or we can say that it is in the closed condition. Okay, what we are assuming? We are assuming that the condition is the normal condition and circuit breaker contact is in the closed condition. Okay, closed condition, that means the moving contact is closed with the fixed contact. Okay, so here This is the blue color is the fixed contact and pink color that is the moving contact. Okay, so there is a physical connection between these two contacts. Okay, here is, and this physical contact of moving contact with the fixed contact is known as the depth of engagement, or we can say that the vibe. So this portion connection of this moving contact with the fixed contact, so this portion is known as the depth of engagement, physical connection between moving contact and fixed contact. The area of connection of moving contact with the fixed contact, that is known as the depth of engagement, or we can say that it is vibe. Understood what is depth of engagement or vibe? Depth of engagement, that means the physical connection of fixed contact, that is known is the depth of engagement. Okay, so in normal condition, when circuit breaker contacts are closed, at that time there is some portion in which portion the fixed contact and moving contacts are physically connected, and this portion is known as the depth of engagement. Okay, now we assume, okay, here is the city is connected, so this city sends the current. Okay, so in normal condition what happens, the current flowing through this wire or the circuit, okay, is normal. Okay, so this current sensed by the city is also normal. Okay, so at that time what happens, the secondary current flowing through the city is also normal. So at that time the current flowing through the secondary of the city is not capable to energize the trip coil. Okay, so it is not capable to energize a trip coil. That means what happens, it is not capable to this, in this operating mechanism there is no force capable to bring this handle in this direction, right side direction. Okay, so the whatever force produced by this operating mechanism, or we can say that the automatic mechanism is not capable to move this handle in right direction. So what happens, the physical connection between fixed contact and moving contact remains as usual. Okay, same, there is no change in the physical connection between fixed contact and moving contact. Okay, now we assume that the fault occurs in the circuit. Okay, so as soon as the fault occurs, what happens, the fault current increases, and this fault current is sensed by the city. Okay, so as soon as the fault current sensed by the city, the current flowing through the secondary is also increases. Okay, so now the current flowing through the secondary of the city is also flowing through the trip coil because it is connected in the secondary of the city. So now what happens, the current fault current also flowing through the trip coil. Okay, so now what happens, now due to this current flowing through the trip coil, so this trip coil is energized. Okay, now due to the energization of this trip coil, what happens, now this force produced is now enough, or it is the force produced is now capable to bring this handle into the right direction. Okay, so whatever force, or we can say energization force produced by this coil is capable to bring this handle into the right direction. So now what happens, this pink contact, that is the moving contact, so this moving contact slides under the sliding contact towards the right direction. Okay, and it slides up to which point, until the disconnection between the fixed contact and the moving contact. Okay, so whatever force produced by this strip coil is now capable to bring this handle into the right direction, and due to it this moving contact slides in the right direction. Okay, so what happens now, it slides in right direction, that means it will try to open the fixed contact from the moving contact. Okay, and at one point this moving contact becomes open from this fixed contact. Okay, so in this manner this circuit breaker operates. Okay, so this is the automatic mechanism. So this automatic mechanism, this brings back this handle into the right direction, and due to it the context becomes open. Okay, so this is the schematic diagram of a circuit breaker, how the circuit breaker operates when fault occurs in the system. Okay, in normal condition there is no need to open the contacts, but if we want to do the maintenance, then we will make the circuit breaker contacts open. So we can manually, this is the automatic operations, we can manually also open the contacts of the circuit breaker. Okay, so the circuit breaker is a switch which we can operate manually as well as automatically. Okay, in faulty condition as well as in normal conditions. Okay, so in both conditions we can operate the circuit breaker, normal condition as well as the faulty conditions. So this circuit breaker is used to make the circuit. After opening the circuit breaker, we need to close the circuit breaker circuit once again. So it make the circuit, make means to close and break means to open. Okay, so circuit breaker is used to open and close the circuit manually as well as automatically in normal condition as well as in faulty condition. Okay, understood. Now hers available chair Kripal,
Yes, sir.
what is depth of engagement here? Okay, this portion is the depth of engagement. Okay, so how can we define the depth of engagement? Another word is wipe. Okay, in this circuit schematic diagram, this portion is known as the depth of engagement. So how can we define it? So physical connection between fixed contact and moving contact, the area in which there is a physical connection between fixed contact and moving contact is known as the depth of engagement. So this portion is known as the depth of engagement. Okay, so in this manner the circuit breaker will operate. Now the classification of circuit breaker. So classification is done on various factors. Okay, so first factor, that is the based on interrupting medium. Okay, now in circuit breaker the interrupting medium, or we can say that the arc quenching medium. Now what is this arc quenching medium or interrupting medium? So when circuit breaker, in previous schematic diagram, when the circuit breaker contacts become open, at that time what happens, due to the high fault current, the arc is produced in between the fixed contact and moving contact. Okay, this is the fixed contact, this is the moving contact. Okay, so when this moving contact slides in the right direction, and at the point when both these contacts becomes open, at that time due to the high fault current, arc is generated. Okay, and whatever arc generated in between these two contacts, that arc we have to extinguish. Okay, and for that medium is used, and this medium is known as the arc quenching medium, or we can say that the interrupting medium. Okay, so based on interrupting medium, circuit breaker is classified as air brake circuit breaker, air blast circuit breaker, oil circuit breaker, vacuum circuit breaker, and SF6 circuit breaker. Okay, so in air brake circuit breaker, the normal, just we define all these circuit breakers based on the interrupting medium. So in air brake circuit breaker, what happens? The natural pressurized air is used to quench the arc. Okay, we are not used the high pressurized air. It is the normal temperature and pressurized air. Okay, so NTP. Okay, so in this air brake circuit breaker, the arc is quenched by using the natural air. That's why it is known as the air brake circuit breaker. And second is the air blast circuit breaker. So in air blast circuit breaker, the arc quenched by the pressurized air. It is not normal temperature and pressure air. Okay, it is a pressurized air. So compressor is used, and with the help of this compressor, the pressurized air is blast on the arc. Okay, so by using this pressurized air, the arc is quenched. That's why the name is given is the air blast circuit breaker. Next circuit breaker, that is the oil circuit breaker. Okay, so in oil circuit breaker, we are using insulating oil to quench the arc. So in oil circuit breaker, the oil is used for two purposes. One is to quench the arc, as well as for to provide the insulation. Okay, so here oil is used to quench the arc. That's why the name given, that is the oil circuit breaker. Next is the vacuum circuit breaker. So in this, the vacuum is used to quench the arc. So whatever arc generated in the circuit breaker, that is quenched by the vacuum. That's why the name given is the vacuum circuit breaker. And last one is the SF6 circuit breaker, sulfur hexafluoride. Okay, the name of this gas, that is the sulfur hexafluoride, SF6. So here SF6 gas is used to quench the arc. Okay, so it is a electronegative type gas. The one property of this SF6 gas, that is the electronegative type gas. Okay, and this SF6 gas is used to quench the arc. That's why the name given, that is the SF6 circuit breaker. So this is the basic information of the circuit breaker, which is classified on the basis of interrupting medium or arc quenching medium. Okay, second is the based on service condition, in which service we are using the circuit breaker. Okay, so whether it is of indoor type or the outdoor type. Okay, so based on service condition, the circuit breaker is classified as indoor type or the outdoor type. Next classification is based on operation. Okay, so in which type of operation occurs in the circuit breaker. Okay, so it is a gravity opened type operation or gravity closed type operation. Another operation is the horizontal brake type operation. Okay, so basis of the operation, how the circuit breaker operates. So it is a gravity opened, gravity closed, and horizontal brake type operation. Next is the based on context. So which type of context I used. So according to that, the circuit breaker is classified. Okay, so based on context, it is classified like butt type circuit breaker, wedge type circuit breaker, laminated flat contact type circuit breaker, bayonet type circuit breaker, explosion chamber type circuit breaker, and beyond grid type circuit breaker. So these are the various contexts which are used in the circuit breaker, and according to it, it is classified. Okay, so based on context, we have a different types of circuit breakers. So we are using different type of context. Okay, next is the based on action, which type of action is done in the circuit breaker. Okay, so it is of two type, that is the non-automatic type and automatic type. Okay, so we are using automatic type action in the circuit breaker on non-automatic type action in the circuit breaker. So basis of it, it is classified in the two categories. Then based on control method, Okay, based on control method, that means whether it is of direct control method or the remote control method. Okay, so in a remote control method we have a different control method, that is the manual control method, pneumatic control method, and as well as the electrical control method. And in electrical control method, whether it is of motorized electrical control method or solenoid type electrical control method. So based on the control method, it is classified like this. Another classification is based on tank construction. So which type of tank is used in the circuit breaker? Okay, so whether it is of separate tank for each pole, okay, or one tank for all pole. If there are 3 poles, okay, so for 3 poles, if we are using separate tank for each pole, so it is classified as separate tank for each pole. And if we are using only one tank for 3 pole, then it is classified as one tank for all pole. Okay, so based on tank construction, it is classified like this. And based on mounting, so how it is mounted? Okay, so it is mounted like it is classified into 3 categories, that is the panel mounted on front side, panel mounted on front side, and second, that is the panel mounted on rear side. Okay, so front panel mounted, rear panel mounted, and remote from panel. It is not mounted on panel, but it is mounted on a remote side from the panel. Okay, so on based on mounting, it is classified into mounted, rear panel mounted, and remote from panel. Okay, so this is the classification breaker based ba- based on circuit interrupting medium, air brake circuit breaker, air blast circuit breaker, oil circuit breaker, vacuum circuit breaker, aseptic circuit breaker. Based on service condition, it is indoor type, outdoor type. Based on operation, gravity open, gravity closed, horizontal brake type. Based on context, butt type, wedge type, laminated flat contact type, bayonet type, explosion chamber type, beyond grid type. Based on action, it is non-automatic and automatic. Based on control method, direct control method, and a remote control method. In a remote control, we have a manual, pneumatic, and electrical. In electrical control method, we have a motor type and solenoid type. Based on tank construction, it is separate tank for each pole, one tank for all pole. And based on mounting, front panel mounting, rear panel mounting, and remote from the panel. Okay, now next is the different types of circuit breaker. Okay, so which we are going to study in this switchgear and protection. Okay, so mainly we are going to study the oil circuit breaker, air brake and air blast circuit breaker, aseptic circuit breaker, and vacuum circuit breaker. These are the main circuit breaker which we are going to study in the circuit interrupting devices in subject of switchgear and protection. Okay, so in next lecture we will discuss the oil circuit breaker. Okay, so general introduction about oil circuit breaker. Just look at the basic information of oil circuit breaker. In oil circuit breaker, insulating oil is used as a quenching medium, arc quenching medium. With the help of this insulating oil, we can quench the arc, whatever arc generated during the separation of the contacts. Okay, so insulating oil is used as a quenching medium. Okay, now what happens when arc is generated in between the fixed contact and moving contact? At that time, heat is produced. Okay, so whatever heat is generated due to the arc has a high temperature. Okay, so due to the heat of arc, decomposition of oil is occurred. Okay, so temperature of the heat is very high, and due to it what happens, the decomposition of oil is occur. And when decomposition occurs at that time, what happens? It produces hydrogen gas, and its volume is 1,000 times more compared to the volume of decomposed oil. Understood? When decomposition of oil occurs at that time, what happens? It produces the hydrogen gas, and the volume of the hydrogen gas is 1,000 times more compared to the volume of decomposed oil. And this hydrogen gas absorbs the heat of the arc, and this arc is being extinguished by the hydrogen gas. Okay, understood now? We are using insulating oil as our quenching medium. Now when short circuit occurs, at that time the circuit breaker becomes open, context becomes open. So while context becomes separated, at that time the arc is generated, and this arc has the high temperature. And due to this high temperature, what happens? Decomposition of oil is occurred, and due to this decomposition of oil, hydrogen gas is generated, and this hydrogen gas has volume of 1,000 times compared to the volume of decomposed oil. And this hydrogen gas absorbs the heat of arc. It absorbs the heat of arc, and due to the absorption of heat of arc, what happens? The arc is being extinguished. Okay, so in this manner this oil circuit breaker operates. Now, which are the advantages we are getting? So hydrogen gas has good cooling property, so quenching of arc becomes speedy. Okay, this is the advantage, that it has a high cooling property, so quenching of arc becomes speedy. Oil has insulating property, so ground clearance requirement is less. Okay, I already told you that this insulating oil is used for two purposes. First, to quench the arc, and second, to provide insulation. Okay, so this insulating oil has a good insulating property. Okay, so ground clearance we need is also less, whether while in other circuit breakers the ground clearance requirement is more. Okay, oil is also work as a cooling material. So these are the advantage of oil circuit breaker. Now, which are the disadvantage we are getting from this circuit breaker? That is, the oil is highly inflammable. Okay, we already knew that oil is highly inflammable. Second, due to the decomposition of oil, possibility of blast is there. So when decomposition occur, how decomposition occur? Due to the high heat of arc, decomposition of occur, and this oil is highly inflammable. That means there is a possibility of blast. And due to the operation of circuit breaker, the carbon produces in the oil. When decomposition occurs, at that time another particles are produced, that is of the carbon. Okay, and due to the carbon particle produced in the oil, it reduces the dielectric strength of the oil. Okay, so after some operation we have to replace this oil, because the dielectric strength of oil reduces. Okay, so these are the disadvantages we are getting from the oil circuit breaker. Okay, now the types of oil circuit breaker. So first, there are mainly two type of oil circuit breaker, that is the bulk oil content type circuit breaker and minimum oil content type circuit breaker. Bulk, that means more, and minimum that means less. So bulk oil type circuit breaker, there are more oil is used, whereas in minimum oil type circuit breaker less oil is used. Okay, so in bulk oil type circuit breaker we have a different types, like plain break type circuit breaker, arc controlled type circuit breaker. These are the two types. Okay, and in plain break type oil circuit breaker we have a two type, that is the single break type and double break type. In single break type there is only one break of the context. Okay, we can say that there is only one connection which we are breaking, whereas in double break type there are two connections which we are breaking. Okay, so it is known as the single break and double break type. In arc controlled type circuit breaker we have a two types, self blast type and forced blast type. Okay, in forced blast type we are providing extra force to quench the arc. Okay, whereas in self blast type we are not providing extra force. Whatever force generated in itself, by using it we can control the arc, okay, or we can quench the arc. Okay, so in self blast type we have a plain explosion port type circuit breaker, cross jet explosion port type circuit breaker, and self compensated explosion port type circuit breaker. Okay, so this is the classification of the circuit breaker. Okay, next we will discuss one by one circuit breaker, that is the plain break type, single break type, and double break type, arc control, self blast, force blast type, and then the minimum oil content type circuit breaker.